class, and welcome to lesson 5.6. Today we're doing the second part of this unit, which is the solving part. So up to this point you should have written a test on algebra and factoring. We are going to use that, mainly the factoring part, to help us solving. So before lesson 5.6 we had expressions. Today, instead of having just expressions, we're going to have equations, which means they're going to equal 0. Okay, so we're going to focus mostly on trinomials or binomials that equal 0. All right, so let's take a look, folks. Up to this point, we've been able to common factor, and you always common factor first, so always do this first. And hopefully you learned on your unit test that you were doing factoring first, and then you might have been doing some trinomial decomposition or difference of squares after that as well. So your other ones are simple trinomials where a equals 1, okay, and decomposition ones where a does not equal 1. That's where you split the middle term. And the last one was the difference of squares method. All right, the entire point of factoring, or why we spend so much time factoring, guys, is to be able to solve for values of x. Okay, so note a quadratic equation is in the form ax squared plus bx plus c equals 0. We're going to put it equal to 0, folks, because we're going to be looking for the number of solutions. When we solve a quadratic, we are actually looking for the x-intercepts, which you're going to learn down below. Okay, so if you're looking for the x-intercepts, to find the x-intercept, you let y equal 0. So that's why instead of having it equal to y, we have it equal to 0, because we're actually finding the solutions which occur at the x-intercepts. So that's why y equals 0. All right, so the graph of a quadratic equation is nonlinear. In fact, it's called a parabola, or in some parts of the world they call it parabola. And it can have 3 different outcomes, meaning the number of solutions. So you can have one solution or one root. That's another name we're going to learn today. And to show that, folks, the vertex has to be on the x-axis. The parabola can open up, or it can open down, anywhere along this, ladies and gentlemen. So that's an example where you have one root, or one solution, or one x-intercept. They're all the same name. Okay? An example where we have 2 solutions is if the vertex is below and it opens up. So you can see easily, folks, that there's 1, 2 for that. Or you could have a parabola that opens down but starts with the vertex above the x-axis. And again, that's another example, 1, 2. So if there's 2 solutions or 2 x-intercepts, we call that 2 roots. Or zeros, actually, as well. Lots of names for those, okay? Now, the last possible way, and this happens quite frequently in life when you take a look at quadratics, is there's no solution. Which means if I got a vertex here and it doesn't cross the x-axis, that means it must open up. Likewise, if I have a vertex that's down below, it must open down, because these arrows continue as we go left to right. And this is an example of no roots. All right? Awesome. So total possible number of solutions is either going to be 1, 2, or none. And we're going to learn through 3 different methods of solving, and it'll apply to these as we go. All right, taking a look here. When we solve by factoring, okay, this is the method we're taking a look at today, we will be finding the x-intercepts. To find the x-intercept, we call these the roots. Okay, and since the x-intercepts occur where y equals 0, we let the equation be set to 0. Okay, so I already explained that. That's awesome. Now we're going to use something new today, guys, and this is new. Okay, and this is important to the factoring method, and it's called the zero product property. Okay, think, ladies and gentlemen, if you take a look, I'm just going to simplify this. A, B equals 0. Now we've got an equation where the left side has to equal the right side. So if we know the right side equals 0, how do we solve for these variables so that the left side equals 0? Either A has to equal 0, because 0 times B is 0, or B has to be 0, because A times 0 is 0. All right. Likewise, we can do the same thing if we have one binomial times one binomial equaling 0. Either the first binomial has to equal 0 or the second binomial equals 0. What does that look like, folks? Say we factored an equation that has x plus 4 times x minus 7 equals 0. Okay, so in order for the left side to equal the right side, we have to say, hey, in order for the left side to equal 0, each bracket has to equal 0. So I'm going to break it into a t, and I'm going to say, hey, x plus 4 equals 0. Now we've got to solve for x. So x equals, you take the plus 4, bring it over, becomes negative 4. Okay? Likewise, the second bracket, x minus 7 equals 0. You take the negative 7, you bring it over, becomes positive. All right? All right, so let's try some examples. Okay? And here are our steps. Okay? Step number 1, move all terms to the left side and get right side equal to 0. We need to do that. Then we factor. Okay? Then we set each factor equal to 0. And if we need to check it, you sub the roots or your solutions into both the left side and right side. Check. And if there's 2 roots, you got to do 2 solutions, or 2 checks, I should say. Okay? All right, example 1, solve by factoring and check A and B only, or A only. All right, so the first thing to take a look at is our method of factoring. Taking a look at number 1, all the terms are to the left side already, we're good. Number 2 says to factor. So looking here, folks, we're going to common factor, and what goes into both those terms? A 3 and an x. So we're left with x minus 3 equals 0. Once we have factored fully, now we have to use the zero product property. What does that mean, folks? That means either the 3x has to equal 0, or the other factor, which is x minus 3, has to equal 0. Okay? Now we solve for x. Currently it's 3x, so to get x by itself, you divide by 3. Whatever you do one side, you do the same to the other. So x equals 0 divided by 3 is 0. There's one solution. And the other one, ladies and gentlemen, x equals, take the negative 3, bring it over, it becomes a positive 3. Okay, so what does that tell us, folks? Yes, we've solved it, but let's just do a quick visual, folks. Okay, if we have a graph x and y, look at A. A is 3, folks, right up here. A is 3, so that means it opens up. So we know we have a solution or an x-intercept at 0 and at 3. So our vertex has to be below since we know it opens up. So we just found some pieces of the information. Okay? If you're curious, folks, we'll be focusing on the vertex in Unit 6. Okay? But right now, and for the rest of this unit, we're focusing on the x-intercepts or solutions. Okay? Awesome. Taking a look at example B. To start off with, not all the same terms are on the left side, so we're going to move everything to the left. So we're going to go 2x squared plus 6x. The negative 4 comes over, becomes a plus 4, equals 0. Okay, taking a look, folks, can we common factor anything out? Okay, yes, we can. However, when we have an equation, we can divide everything by 2 in this case. So instead of leaving the 2 out front, I'm just going to write down divide by 2. Okay. And when I divide by 2, I'm just going to divide everything, because 0 divided by 2 is still 0. So we've got x squared plus 3x plus 2 equals 0. All right. Okay. Then what we need to realize is, hey, we've got a trinomial factoring here. So product equals 2, sum equals 3. Our numbers are 1 times 2. So we know we're going to have x plus 1 times x plus 2 equals 0. And then we set each factor to 0. So x plus 1 equals 0, which means x equals negative 1 when you bring that over. It's one solution. Okay. And x plus 2 equals 0. Bring the positive 2 over, becomes a negative. Sorry, my fault. Bring the 2. Let me erase that. Take the positive 2, bring it over, becomes a negative 2. Okay, so ladies and gentlemen, I'm just checking my notes, and I forgot to check equation A. So just give me 1 second, folks. I'm going to have to see if I can hop on here and give me some more room to do a check. Sorry, guys. Asked me to check A, so we'll do a check. Okay. So I apologize. Let's just back up here for a second. So we're going to do a check. And because we have two solutions, we have to do two checks. Okay? Don't ask me what I just felt there. Let's try that again. Check. All right. So we're going to check x equals 0 over here. And then we'll check x equals 3 on this one. Okay, you have to go back to your original equation for left side and right side. So it's going to be 3 equal 3x squared minus 9x, okay, equals 0. So you're going to sub in 0, so it's going to be 3 times 0 squared minus 9 times 0. Okay, that's going to be easy. 0 squared is 0 times 3 is 0. If 0 subtract 9 times 0 is 0. It equals 0. You can go right from here to there. I'm okay with that. Let's try the next one. So we already have it written down, so you can just sub it right in. So it's going to be 3 times 3 squared minus 9 times 3. So 3 squared is 9. Subtract 9 times 3. So we got 27. Subtract 27. That equals 0. And what does the right side equal? 0. So since left side equals right side, therefore solutions are correct. Okay? All right. I apologize for forgetting that check. Let's move on to another one here. C. Taking a look at C. All right. Can we common factor or divide every term by a number? No. But what we notice is we've got a product of 21, a sum of negative 10. Our two numbers are going to be negative 3 and negative 10. Sorry, negative 3 and negative 7, my fault. Okay. So then we set up our brackets. X minus 3 times x minus 7 equals 0. And folks, you can develop this. If you still need to write it out, go for it. But what number do you sub in for x here so that this becomes 0? You're just going to write down x equals 3. Okay? And here, what number do you sub in for x so that this bracket, second binomial, becomes 0? It's going to be a 7. So you can just go right like this. I'm fine. However, if you need to put it under the t-chart and move it over, I'm okay with that. All right, so just a quick visual, folks. If you're wondering what that is, have a intercept at 3, have one at 7, and direction of opening is up because A is positive 1. Okay, so we're just finding those solutions or x-intercepts. Awesome. Okay, take a look at the next one here. Again, we don't have one side equal to 0, so we're going to move that term over. So positive 3x becomes negative 3x. Okay, now we take a look in our brackets here, or in our side, we've got a product that's negative 54, a sum that equals negative 3, and that's 6 times negative 9. Hopefully you're good at that, finding those out. So because it's simple trinomial, you're going to go x plus 6 times x minus 9 equals 0. Let's try that shortcut again. To get this bracket to equal 0, x has to equal negative 6, right? It's kind of like the opposite of what you see when it's a simple trinomial. Okay? Whereas this one, folks, you got to put in 9 because 9 subtract 9 equals 0. All right. Now, whenever we have a decomposition, it's going to be a little harder. And, woo, looks like I forgot when I moved the shift down that we got this box in the way. So, let me just see if I can shift this down, and where did my homework go? Where did my homework go? Let's see if I can get that back. All right, sorry guys. Trying to make sure I got enough room here. There we go. Apologize for the wasting of the time there. All right, so taking a look at E, we've got a decomposition. So product equals A times C, so that's negative 6. And our sum equals 5. Okay, so what two values do we have there? Hopefully you got negative 1 times 6. So you're going to split the middle terms. You're going to have 2x squared, leave that one the same, plus 6x. I always try to keep the positives together, and then I'm going to put minus 1x minus 3 equals 0. Okay? Collecting like terms in the first two terms, I have a 2x, so I'm left with x plus 3. Taking a look at the second one, I've got a -1, so I'm going to have an x plus 3 equaling 0. My common binomial is x plus 3. And I have 2x minus 1 equals 0. So the first one is pretty self-explanatory, which is x plus 3 equals 0. So that means x equals -3. That one should be simple, but the other one's not so easy. So it's going to have a fraction. So 2x minus 1 equals 0. 2x equals 1. To get x by itself, divide both by 2. So x equals 1/2. That's the key for decomposition. You'll always have at least one fraction. All right. Last question, folks. We can do this. All right. What do we need to do? First of all, step 1, get all your terms to the left side. So y squared is already here. Let's combine the y's. So we got positive 9y. When we bring the positive 2y over, it's become negative 2y. So you're going to have with plus 7y. Okay, and then we've got plus 15. When you bring the positive 5 over, you're going to have plus 10 equals 0. Okay, good news is, guys, that's a simple trinomial with a product equaling 10 and a sum equaling 7. Our two numbers there are 2 and 5. Okay, so we've got y plus 2 times y plus 5 equals 0. Okay, zero product property, get the opposite of what you see when it's simple. So y equals -2 or y equals -5. Okay, awesome. Now just to summarize here, guys, when solving a quadratic, you are finding what we call the solutions. That's one term, we call it. Or we call it the roots. Or if we're dealing with a graph, it's the x-intercepts. And sometimes when you're dealing with graphing calculator, they call them the zeros because it's when y equals 0. Okay? All right, folks, here's your homework, page 255. 1 ABC, 2 ABC, 4 ABC, 6 ABC, 8 ABC, and 11. Have fun doing your homework. And again, if you need some help, let me know. Have a great day.